Hello and welcome to this video about impedance matching. As you see in the first video, you learned how to do the impedance matching using Altium impedance calculator tools. And this video, I will talk about how to do it in JLCPCB. So the principles are the same when we did the differential pair for the USB and we matched them with 90 ohm impedance. But here we will do it for the RF line. So I have this PCB, which is a LoRa device. It's called RN2483. And this IC, it has two different antenna you can connect with two different frequency, 868 and 433. So this trace here, it needs to be matched with 50 ohm between the SMA connector and the RF pin here. So you notice I have a ground plane on the top layer, and now we will see why I added this ground plane on the two layer, especially if you have a two layers PCB. So if I go to JLCPCB impedance calculator, then I can select that I have two layers. PCB thickness, so this is from the stack up, which is 1.6 for two layers. Outer copper is 1 ounce, and then the unit millimeter. So if I put 50 ohm, single ended, so this means none coplanar. So it means I don't have a polygon basically here, which is close to my RF trace here. So if I make the calculation, I will get that I need a trace width with 2.7. And that's really not possible. So if I put the trace width here, 2.7, look what we have. So if I don't have this ground plane, I need to make my trace here 2.7, and that's not possible. That's why I added this ground plane on the top layer, and let's see how the calculation change. So first I selected the coplanar single ended because I have a ground polygon on the top layer. And then I selected the impedance trace to copper. So this is the distance between the copper and the trace. Then I got this number here, 0.622. So you can see the difference. My previous number, it was 2.7, and here I got 0.62. Then I go to Altium, and then so this 0. So it's almost 0.62. Then I make it 0.623, and that's how I match 50 ohm trace here. So one thing you notice, the routing technique I used is different from the normal routing you do, the 45 degree. And that's because I have two antennas. So if I have one antenna, then I will just bring this antenna to here, and then I will have a straight line from here to here. Yeah. But then those antennas also, if I want to bring this close, I don't have really space. So that's why I need to make them like this, and I put them on the edge of the PCB, as you can see. So when you do that, when you have to go from this pin and then go over this pin, I advise you to not use the 45. So if you Control W, then so we're using normally this connection. Then I advise you to use this one, and then you simply select the trace width 0.632, and then you just route it something like this. Sometimes the routing will be a little bit messed up. Yeah, so something like this is perfect. And then also to make them identical, you can just click the trace, press tab, and then Control C, and then left click on the mouse, then Control V, then Shift and X, and then you can just place it like this. Then they will be exactly the same. So you have to delete this basically, and then place it again. Yeah. So that's about the impedance matching. And you also saw I add a lot of vias here. That's what the datasheet recommended. And also, as I said, the vias are free. So it's a good idea. You can see all my board. I add stitching vias in all my board. So I have so many vias in all my board. And that's it about this video. Thanks a lot.